Hi everyone, Mr. Boltri here, bringing you video 5.1, where I'm going to take you through setting up the ball on the incline lab, which is going to be our Unit 5 introductory lab. To do this, please flip to the next available page in your lab notebook and title the page Ball on an Incline Lab. As with every lab this year, we're going to start the lab with a question. So the question on this lab is going to be, what does the position and time graph look like, or what is the relationship between position and time for a ball as it's rolling down an incline or a ramp? So to give you a sense of what this lab is going to look like, so that we can be prepared to run it in our next class, every group is going to get an incline that looks like this. It's just going to be a ramp. And you can notice on the ramp that there are markings for every centimeter. You're also going to get a steel ball and a stopwatch or a timer. So to represent that in a sketch in our lab notebook, we have a ball, an incline, a timer, and just make sure that you note that the ramp is marked for every centimeter. You could also use a ruler to measure it, but it's just going to be easier to use the markings on the ramp. For our procedure, and again, I just kind of want you to set up your lab notebook so that when we come to class, in our next class, you'll be able to run it basically right away without needing any instructions from me. So the procedure is going to be pretty simple. We're going to take the ball, we're going to put it at the very top of the ramp. So it's going to be a position of 0 centimeters. We're going to start the timer and release the ball at the same time. And actually, you might want to put a note right here to say that it probably works best if the person who is releasing the ball is also the same person who's starting the timer, just to make sure that they are perfectly in sync. Then we're going to let the ball roll for half a second, and we're going to stop the ball and record its position after half a second. Then we're going to kind of restart the whole process and do it for, instead of half a second, we'll do 1 second. Then we'll do the same thing again for a second and a half, and then 2 seconds and on from there. So your data table is going to look something like this. You're going to have seconds from 0 seconds up to 4 seconds in half-second increments. And you're going to, after half a second, record the position in centimeters of the ball. Then for the analysis, it should be pretty simple. We're just going to graph it, making sure to put the position on the vertical axis. And I'm actually going to give you a step-by-step guide in our next class to have you graph it. Instead of graphing it by hand in your lab notebook, I'm going to show you how to graph it using an online tool called Desmos. So your analysis, just because this is going to be an online tool, is just going to be to graph the data, and then we'll save any sort of linearization or tangent slope calculation. We'll save that for the following class. So in our next class, make sure that you come with your lab notebook all set up to collect all of your data. And then for homework, you're just going to graph your data. I'm looking forward to running this lab with you in our next class, but until then, go Bears.